So here we have a system of linear inequality. That means we have two linear inequations and we have to find a solution that satisfies both the two linear inequality. So let's begin. So we'll label them as equation number 1. It's not an equation, it's an inequation. Inequation number 1 and inequation number 2. Let's start with inequation number 1. So here we are given 5x divided by 4 plus 3x divided by 8. This is greater than 39 divided by 8. Now what we'll do, we'll transpose 39 over 8 to the left hand side. That gives us 5x over 4 plus 3x over 8 minus 39 over 8 greater than 0. Now we'll combine the three terms. So we'll take a common denominator, which is 8. So for the first term, the numerator will be 10x plus the second one will be 3x minus 39. So this is greater than 0. So 10x plus 3x, that's 13x. So 13x minus 39 divided by 8, which is greater than 0. We can take 13 as the common factor in the numerator. So we have 13 multiplied to x minus 3. And we have 8 in the denominator. So we have 13 over 8 multiplied to x minus 3. So that's greater than 0. Now what we'll do, we'll multiply both sides of the equation with 8 over 13. So we have 8 over 13 multiplied to both sides of the inequality. Now when doing so, the sign of the inequality is not going to change. Here we will be using a property. That means if, let's say, we have a number a which is greater than b, and we have another number c which is a positive number, meaning it is greater than 0, then it immediately follows that if we multiply a with c and b with c, then the sign of the inequality is not going to vary. That means ac will be greater than bc. So in our case, we will now obtain x minus 3 greater than 0. So solving this inequality gives us x greater than 3. So this is one solution, which is a solution that satisfies inequation number 1. So let's label this as number 3. Now we will consider inequation number 2. So we'll transpose 3x plus 1 over 4 to the left hand side. This will give us 2x minus 1 divided by 12 minus x minus 1 divided by 3 minus 3x plus 1 divided by 4 less than 0. Now, for the first term, we keep it as it is. We have 2x minus 1 divided by 12 minus. So if we consider the denominator of each of the three terms, the least common multiple will be 12. So what we'll do, we'll try to make the denominator of the second term and the third term 12. To do that, for the second term, we'll multiply both the numerator and the denominator with 4. So that gives us 4x minus 4 divided by 12 minus, to make the denominator of the third term 12, we'll multiply 3 to both the numerator and the denominator. So in the denominator we have 12 and in the numerator we have 3 multiplied to 3x plus 1. So that gives us 9x plus 3. This is less than 0. Now that we have all the denominators equal, we can combine the numerator. So we have 2x minus 1 minus 4x. So we have minus of 4x minus 4. That gives us 4x minus 4x plus 4 minus 9x minus 3. So this is less than 0. So we have 2x minus 4x. So that's negative 2x. Negative 2x minus 9x. So that will be negative 11x. We have negative 1 plus 4. So that's positive 3. And positive 3 minus 3 will give us 0. So we have negative 11x divided by 12. So this is less than 0. Now what we want to do, we want to get rid of the coefficient of x, which is negative 11 over 12. That means we will need to multiply it with negative 12 over 11. So if we multiply with negative 12 over 11 to negative 11x over 12, so that will make the coefficient of x positive. So we'll have to do that to both sides, but this time we have to be very careful here because we are multiplying by a negative number. So here we'll use the property. Let's say if we have a less than b and another number c, which is a negative number that is less than c, then if we multiply a with c and b with c, a negative number c, then the sign of the inequality changes. That means AC will become greater than BC. Right. That means it's very easy to remember. Let's say we have 3 less than 5. If we multiply both sides with -1 or any negative number, using -1, that's a simple case, we'll have -3 and -5. We know that -3 is greater than -5. So we can see here clearly that the sign of the inequality changes when we multiply with a negative number. Right. So that means our inequality, which was initially less than 0, will now become greater than. So that gives us x greater than 0. This is a solution to our inequality number 2. So let's label this as number 4. Now what we have to do, we have to find a common solution using 3 and 4 that satisfies both the two linear inequality. So let's do that. So in one case we have obtained x to be greater than 0, and in the other case we have obtained x to be greater than 3. Right. We will consider a number line. On the number line we will take 0, x equals to 0 and x equals to 3. So here x greater than 0 means we'll have to consider all the values of x which is greater than 0. That means lying to the right of x equals to 0. And I've used a bubble. That is because 0 is not a part of a solution. We have x greater than 0. And for x greater than 3, we have to consider all the values of x that lies to the right of x equals to 3, and 3 is not included. And here we'll see that the common solution will be this particular region. So this is common to both the two solution, that's x greater than 0 and x greater than 3. So we'll say that the common solution is going to be x is greater than 3. And if we want to write it in the interval form, that will be 3 comma infinity, and we have to use an open interval because infinity is always unbounded. That's why you use an open interval, and 3 is not a part of the solution, so this is going to be an open interval. So this is a solution that satisfies both of the two linear inequality, or we can say it's a solution that satisfies the system of linear inequality.